All right, so now let's do part B of 316, where we have to find the we have to find the local x displacements using the global displacements given. Right, U1, V1, U2, and V2. And they also give us the properties of the beam, or the bar in this case, right? It's E, A, and L. So let's go ahead and get started. All right, so just like the other one, we're not going to need E, A, and L because we're going from global to local. And to do that, you just use a transformation matrix. I didn't mention it in the other video, but this is the formula. It's a D bar, which is the local displacement, is equal to a transformation matrix multiplied by your global displacement vector. So this D right here is this one right here. These are just given, right? U1, U2, V1, and V2, just in vector form. And we're just looking for this little D bar right here. And we use the transformation matrix to get there, right? So again, we won't really need E, A, and L. So I guess they kind of just gave that to kind of throw you off. But first step, right, it's just assembling this equation right here. So it's going to be U1 prime, V1 prime, right, the X and Y for the local X and Y coordinates for node 1. And similarly for node 2, it's these right here. So it's this vector, that's your D bar. It's equal to the transformation matrix. That transformation matrix is given as cosine theta. And there's a way to derive this matrix right here, but we're not going to go into that, right? It's just using what we know. Cosine theta, this is 0, this is 0, 0, 0. And then this right here is cosine theta. This is negative sine theta. We got sine theta and cosine theta. This is 0, 0, 0, 0. And there's really nothing much to this problem. It's not too hard. It's just basic matrix algebra now. It's 0.50, where I'm just plugging in the U vector now, the displacement vector. 0, got 0.25 and 0.75. And yeah, we would go ahead and start assembling the equations, right? So step 2, it's U1 prime is equal to cosine theta times 0.5. So that's 0.5 cosine of your angle. The angle is negative 30. Again, it's with respect to the positive x-axis. So in this case, it's negative 30 degrees. And that's it, right? Sine theta times 0, 0 times 0.25, 0 times 0.75. Next one, V1 prime is equal to negative sine times 0.5. That is negative 0.5 sine, again, of your angle, negative 30 degrees, plus cosine theta times 0 plus 0 times 0.25. And finally, plus 0 times 0.75. So it's just that one again. Next one, U2 prime. It's only asking for local x displacement, so we only care about U1 prime and U2 prime, but we're just going to go ahead and solve all 4 of them. Same thing. Next one, right? So it's 0 times that plus 0 times that plus cosine times this. So that is 0.25 cosine of theta, right? Then plus sine theta times 0.75. So it's plus 0.75 sine of negative 30 degrees. And that's it for that one. Finally, V2 prime is equal to 0, 0. So it's negative sine times 0.25. So it's negative 0.25 sine of negative 30 plus 0.75 cosine of negative 30. And that's it. You could just, there's no unknowns, right? We could just solve for every single variable. So finally, step 3, U1 prime is going to be equal to 0.4330 inches. V1 prime is going to be equal to 0.25 inches. Let me move it up in case you couldn't see. U2 prime would be equal to negative 0.1585 inches, and V2 prime will be equal, put 2 right here, to 0.7745 inches. Just when you do these calculations, make sure that your calculator's in radians, because that it will mess you up. I mean degrees, right? Because that's gonna mess you up right here. But that's pretty much the answer. That's the top part, and then that's the bottom part.